This is Mrs. Wainwright's Math Class, Chapters 6, 7, and 8, Pkt E Review Sheet Solutions for Test Review. This comes from Review Sheet problem numbers 11 through 15. Let's take a look at number 11. It says equation 1, and it has an equation with fractions, equation 2, equation 3, and equation 4. And the question says which equation or equations are true. So they want to know which of these are actually accurate. Now remember, when there's an equal sign, one side has to equal the other side. They have to be equivalent. So if I want to figure out which equations are true, let's go ahead and try and solve them and see if they actually solve to what it says that it solves to. So I'm going to start with equation number 1. 3/10, and I'll write it down. 3/10, I like to write my problems vertically always, plus 15/100. Let's solve that and see if it equals 18/100. Well, I cannot add them the way that they are because my denominators are 10 and 100. When I add or subtract fractions, I must have common denominators. So if my denominators are different, I need to find the LCD of the denominators to find a new denominator and make equivalent fractions. So I'm going to do that. I'm going to find my LCD. Always fastest to start with your largest number, which is 100, and then my smaller number, which is 10. So when I go through my 100 times tables, well, 100 times 1 is 100. And when I go through my 10 times tables, do I say 100? Well, yes, and I know 100 is divisible by 10 as well from my divisibility rules, because if it's divisible by 10, it ends in a 0, and 100 does. So therefore, yes, when I go through my 10 times tables, I do say 100. So I'm going to make new fractions that have the denominator of 100. So up here, I'll put my fraction bar on 100, and next to this one, I'll put my fraction bar and 100. As always, I will make my window boxes and set myself up. So I say 10 times what equals 100? Well, 10 times 10 equals 100. And whenever I put in the bottom of the window box, I must put on the top of the window box. So I'll say times 10 again, and 3 times 10 is 30. So 3/10 turned into 30/100. Now let's take a look at the bottom fraction, 15/100. What do I do to 100 to turn it into 100? Well, times 1, because it already is 100. Whatever I do on the bottom, I must do on the top, and 15 times 1 equals itself, which is 15. So really 15/100 stayed the same. This is an addition problem, so I'll rewrite my addition sign and my equal bar. Denominators are made the same and they're going to stay the same, so I'll put my fraction bar and keep my denominator of 100. Now I add my numerators, and 30 plus 15, well, 0 plus 5 is 5, and 3 plus 1 is 4. So I get 45/100. Now normally I would look at that and say, oh, I know that's at least divisible by 5. But if I look over at equation number 1, the denominator is still the same, it's 100. And it says in equation number 1, 3/10 plus 15/100 equals 18/100. And it most definitely does not. It equals 45/100. So therefore, no, equation number 1 is not correct. So I'll look down at the bottom at my multiple choices and cross out any ones that say equation 1. Well, I see A says equation 1. Nope, no good, because equation 1 is not correct. B says equation 2, C equations 3 and 4, D equation 2 and 4. So the only one that says 1 is A. I've crossed it out. Now let me move on and try equation number 2. Equation number 2 says 4/10 plus 32/100. Now my denominators are 10 and 100, and those are not the same, so I need to find the LCD. But I do remember in my last problem, when I tried out problem number 1, I did find the LCD for those exact same denominators, 10 and 100. So why do it over again? Use the information on my scrap paper. So I found that the LCD was 100, so I'll make my new fraction bars with the denominator of 100. I will set myself up with my window boxes, so I'm all set to go. And 10 times what equals 100? Well, 10 times 10 equals 100. Whatever I do on the bottom of the window box, I must do on the top of the window box. So I'll say times 10. And now I'll solve 4 times 10 equals 40. Okay, let's move down to the fraction on the bottom, put my window box. 100 times what is 100? Well, 100 times 1 is 100. Whatever I do in the bottom, I must do in the top. So 32 times 1 equals 32. Now I can add these together. The denominators were made the same because they're going to stay the same, so my denominator is 100. I'm going to add 40 plus 32. So 0 plus 2 equals 2, 4 plus 3 equals 7. So I have the fraction 72 hundredths. Again, my initial reaction when I look at that is say, oh, those are both even. I have to be able to simplify. But before I do, let me look up over at my choices. And I see that equation number 2 says the answer is 72 100ths. And that's what I got. So I know right away then that 72 hundredths is the correct answer. So I'll write down a yes next to equation number 2 because yes, that is correct. So let's look down at my multiple choices. I already crossed out A. B says equation 2, so that may be a correct answer. I'll put a question mark there. C says equations 3 and 4 only. Well, that wouldn't be possible because I know equation 2 is correct and it's not listed there. So I am going to cross out letter C. D says equations 2 and 4 only, and since there's a 2 in there and I know 2 is correct, that could possibly be a choice as well. Okay, I'm ready to move on, but look what I notice. I can try equation 3, but I've already narrowed it down to either multiple choice B or multiple choice D. Multiple choice B says equation 2 only. Multiple choice D says equations 2 and 4 only. So 3 is no longer even one of my options. Therefore, I'm not even going to waste my time trying 3. I'll just move down and try equation number 4. And equation number 4 is 6/10 plus 27 hundredths. I look at my denominators as I say, oh, they are not the same, so I need to find the least common denominator. But again, I already found the least common denominator of 110, and that was 100. So I'll make my fraction bars for 100 as my denominator. And I put a window box, and I say 10 times what is 100? Well, 10 times 10 is 100. Whatever I do on the bottom of a window box, I must do on the top of a window box. So 6 times 10 equals 60. Let's put my window box up for my bottom fraction, 27 hundredths. What do I do to 100 to turn it into 100? Well, that's times 1. Whatever I do on the bottom of a window box, I must do on the top of the window box. So 27 times 1 equals 27. My denominators are the same, so now I can add these. Common denominators, the denominator stays the same, so that's going to be the 100. And now I add my numerators. 0 plus 7 equals 7. 6 plus 2 equals 8, so I have 87 hundredths. Let's look up by equation 4. Oh, and that says 87 hundredths. So equation 4 is correct as well. So equation 2 is correct and equation 4 is correct. Let's look down at my multiple choices. B says equation 2 only, and D says equations 2 and 4 only. So D is going to be the correct answer. Equations 2 and 4. Final answer for this question is D. Let's take a look at question number 12. This looks interesting. There's a little picture. Obviously, Mrs. Wainwright drew that picture because it's not really very good. And there's a paragraph. Let's read it and see. Eli lives 3 3/4 miles from the library. You know what? Just like decimals, I'm going to read this as whole numbers. I think it will make it easier to understand. So let's start again. Eli lives 3 miles from the library. There's a picture of his house. I see his distance from his house to the library. He decided to bike from his home to the library to return some books. So I want to picture this and understand it. I'm picturing a boy named Eli. I'm picturing him on his bicycle, and he's going from his house to the library to return books. Okay. Eli bikes 1 mile when he remembered that he left a book at home. So he biked back home to get it. So I'm picturing Eli. He's got like maybe a backpack on with books in it, and he rides for a little while and says, oh no, I forgot this book. So he turns his bicycle around and rides back home. Okay, next sentence. After getting the book from home, he biked to the library. So I picture when he gets back home, he runs inside. I don't know why, but I picture the book underneath his bed on the floor in his bedroom. He grabs it, runs back outside, sticks it in his backpack, gets on his bike, and he rides back to the library. The question says, what's the total distance in miles Eli had biked when he finally reached the library? So it's the first thing that I do for any word problem is I go back to the question mark and up to the asking word. So this full question is in a sentence. What's the total distance in miles that Eli had biked when he finally reached the library? I want the distance in miles, and I want it to be the total distance. Total is the key word that says I'll be adding or multiplying. If it's different numbers that are being put together, I'm adding. And if it's the same number that's happening over and over and over again, then I would be multiplying. And I know if I want the total distance, that makes sense because he didn't just go from his house to the library. He forgot something, went back, and then he went to the library. So let's go back into the question and see what I know. I know he decided to ride from home to the library to return the books, and I know that he biked 1 1/10 miles, and then he remembered that he left a book at home. So that's the first part, or as they say, the first leg of his journey. So I'll write down that amount, which is 1 1/10 miles, and then he stopped. Because that's when he remembered he had a book at home. Okay, let's see what I know next. I know that then he biked back home to get the book. Well, if he biked back home, that's another part of his journey, another part of what he rode, so I'm going to have to include that. But the only problem is, it doesn't tell me how far he rode back home. I have no idea. But let's stop and think about it. If I look back up at the problem or at the picture, did he ride 3 3/4 miles back home? No, because that's the whole distance to the library, and he never got to the library. He stopped at 1 1/10 miles. Think about that. If he rode for 1 1/10 miles, stopped, and went back home, he rode the same amount of miles back home, right? He rode for 1 1/10 miles, went back, he had to go back 1 1/10 miles. So that's going to be the next part of my problem. If he rode back home, it's another 1 1/10 miles, because logically, that's going to make sense. That it's the same distance back home from where he stopped. So that's probably the trickiest part of this problem. Let's see what else we know. Well, we also know that after getting the book from home, he biked back to the library. So what's the distance from his house to the library? Well, it does show me on this little map here. Eli's house to the library is 3 3/4 miles. So after he got his book, he had to make the whole trip to the library, so I'll add on that 3 3/4 miles. Now, why am I adding these all together? Because each distance is different. Technically, if I wanted to, I could have said 1 1/10 times 2, right? He stopped 1 1/10 miles in and went back, and then it could have added on the 3 3/4 at the end. But I find I prefer to do one operation straight through. So that's why I did 1 1/10 till he stopped, the 1 1/10 back home, and then the full 3 3/4 from home to the library. And let's go back into my question. Is there anything else? Nope. Now it actually asks for the question. What's the total distance in miles that he biked when he finally reached the library? So I think I have all of my facts and information. I'm ready to go ahead and solve this problem. So I'm going to move to the next page to add my 1 1/10 plus 1 1/10 plus 3 3/4. Here they are. I wrote them vertically, 1 1/10, 1 1/10 plus 3 3/4. Okay, first thing I need to do when I add fractions or mixed numbers is I need to make sure that I have common denominators. And my first number, my denominator is 10. My next number is 10 again. Oh, that's good. My last number is 4. No, that's different. So I'm going to need to find my least common denominator to make fractions that have the same denominator. So I'll do my LCD. Fastest when I do my largest number first. My largest number is 10. My other number is 4. When I go through my 10 times tables, I say 10. When I go through my 4s, do I say 10? 4, 8, 12. No, I don't. After 10 comes 20. When I go through my 4s, do I say 20? 4, 8, 12, 16, 20. Hey, yes, I do. So 20 is my least common denominator. So I'm going to make new fractions that all have the denominator of 20. Now, as I get ready to do that with a mixed number, this is not a straight fraction over here, these numbers on my left side, these are mixed numbers, I have to remember the whole number, because that's the biggest mistake that I see on math tests with students with mixed numbers, is they forget the whole number portion of the answer, and that makes it wrong. So I'm automatically, when I move my numbers over, going to move my whole number. Now I'll make a fraction bar and put that new LCD of 20. Again, I'll move my whole number of 1 over. Now I'll make a fraction bar, put my new LCD of 20, and on the bottom I'll move my whole number of 3 over, put a fraction bar, and make my LCD of 20. Now I'll set myself up with my window boxes so I can make my new equivalent fractions. So on the top, what do I do to a 10 to turn it into a 20? Well, 10 times 2 is 20. Whatever I do on the bottom, I must do on the top. 1 times 2 equals 2. So 1 and 1/10 turned into 1 and 2/20. Okay, let's take a look at my second one. What do I do to a 10 to turn it into a 20? Well, it's going to be the same thing times 2. Whatever I do on the bottom, I do on the top. 1 times 2 equals 2. So again, 1 and 1/10 turned into 1 and 2/20. Let's take a look at my bottom number. What do I do to a 4 to turn it into 20? Well, 4 times 5 equals 20. Whatever I do on the bottom, I must do on the top. 3 times 5 equals 15. So 3 3/4 turned into 3 and 15/20. So I'm all set up. I can do my plus sign. Remember, I need the plus sign and the equal bar if I want any chance of partial credit. That makes it the equation, and it does need to look like an equation. So I'm ready to add my fractions. I know my denominator will be 20. Let's add my numerators. Well, I'm going to start with my 15 plus 2, which is 17, plus 2, which is 19. So I know that that will be 19/20. Now I have to add my whole numbers, and 1 plus 1 is 2, and 2 plus 3 equals 5. So I have 5 and 19/20. That should be my final answer, but I know before I have a final answer, I have to ask myself 2 questions. And the first question is it a proper fraction? Will it work in a chicken fight? Well, yes, 19/20 will work in a chicken fight, so it is a proper fraction. Good. My next question is the fraction fully simplified? And 19/20 is in counting order, so that means it's fully simplified. So yes, 5 and 19/20 is a fully simplified mixed number answer. Let's go back to my problem and put that in. The final answer we said is 5 and 19/20. Now this is a word problem, so it needs a unit. If I go back first, I look in the question, what's the total distance? In miles. So my answer is going to be miles. 5 and 19/20 miles is my final answer. That's the total distance that he biked when he finally reached the library. Let's take a look at number 13. Jesse set up a lemonade stand for 3 days. So I'm picturing a lemonade stand with a person named Jesse. Remember reading whole numbers. So on Saturday she sold 10 gallons of lemonade. On Sunday she sold 3 gallons more than she sold on Saturday. And on Monday she sold 2 gallons less than she sold on Sunday. Question says, how many gallons of lemonade did Jesse sell on Monday? All right, anytime I have a word problem, first thing I do is go back to my question, which has my question mark to my asking word. And this question is, how many gallons of lemonade did she sell on Monday? There's various days here. I want to know the answer to Monday. I'm also noticing something, and while I'm thinking about it, I'm going to take care of it. It asks for how many gallons. That has to be my unit, and since this is a word problem that's not multiple choice, I'll put that unit in right now so I don't forget. So let's go back and check out our information. Our first bullet says on Saturday, but I want to know Monday. Our next bullet says on Sunday. Nope, I want to know Monday. And our next bullet says on Monday. Perfect. That's the day that I want to know. So let's focus in on this last bullet. And remember, as I read it, I'm still reading whole numbers. I will use the actual numbers when I write down my facts. On Monday, she sold 2 gallons less than she sold on Sunday. So in order to figure out how much she sold on Monday, I have to make it 2 gallons less than what she sold on Sunday. Well, if I want to do something less than, I know that's going to be a subtraction problem. So I have to subtract this 2 from whatever she sold on Sunday if it was 2 gallons less. Alright, so that means I need to look up and see what she did on Sunday. It says on Sunday she sold 3 gallons more than she sold on Saturday. Well, I'm comparing Sundays to Saturdays, and on Sunday she sold 3 gallons more. So I need to add 3 to whatever she did on Saturday. Oh my goodness. So now I have to focus in on what she did on Saturday. And it says on Saturday she sold 10 gallons of lemonade. Well, that's good. I know exactly what she sold on Saturday, and that was 10 gallons of lemonade. So if I take what she sold on Saturday, which is at 10 gallons, and then for Sunday I add 3 to that, that would give me my Sunday total. And then to figure out Monday, I subtract 2 from that, that would give me my Monday total. Okay, so I think I'm ready to start this. So on Saturday, I know that she sold the actual number now, since this is my problem, 10 2/3 gallons. On Sunday, which is my second bullet, I know that she sold 3 3/3 gallons more than she did on Saturday. So I'll start with my Saturday amount, which the actual amount was 10 2/3 gallons, and I'll add those 3 1/3 gallons more, and that will tell me how much she sold on Sunday. Okay, so let's go ahead and do this. My denominators have to be the same to add or subtract fractions, and I see my denominators are 3 and 3. Oh, I like that. They're already the same. Perfect, so I'm ready to go ahead and add. So I put my fraction bar. My denominators were the same, so they're going to stay the same, and now I add my numerators. 2 plus 1 equals 3. Now I add my whole numbers, and 10 plus 3 equals 13. So I know on Sunday she sold 13 3/3 gallons. 13 3/3. If my fraction is not fully simplified and I have more math to do, I don't usually bother simplifying until the very end for my final answer. But I look at 13 3/3 and I know right away that 3/3 is the same thing as 1. So really, 13 3/3 is 13 plus 1, and that equals 14. So for that, since 3/3 is such a simple fraction to figure out, since it equals to 1, I'm going to fix that one right away because I think it will just be easier to work with the 14. So on Saturday, she sold 10 2/3 gallons. On Sunday, she sold 14 gallons. Now I finally get to the day that I want, which is Monday. So let's take a look at the Monday. On Monday, she sold 2 2/3 gallons less than she sold on Sunday. So I'm going to take my Sunday amount, which was 14, and if she sold 2 2/3 less, we said that's going to be a subtraction problem. Whole numbers get lined up in their columns. Fractions get lined up in their own column. So I have 14 minus 2 2/3. Now, this problem, this is the mistake I've been seeing in your classwork recently. I have to think about it as little pieces of Hershey's chocolate. So if I start with 14 whole Hershey bars, can I give you 2 2/3? Can I give you little pieces? No, I cannot, because I don't have any little pieces to give you. So therefore, I have to borrow. I'm going to cross out the 14, take one of those Hershey bars away, which will leave me with 13 whole Hershey bars. Remember, you have to borrow and take away before you can add on. So I have to cross out the 14 and turn it into a 13 before I can put a fraction there. Now that one Hershey bar that I took away, I'm going to picture myself opening up the wrapper. I now have that Hershey bar and I can break it into little pieces. I can break it into any size pieces I want. So if I can break it into any size pieces I want, and this is a subtraction problem, in order to add or subtract, I must have common denominators. It would make the most sense for me to break it into whatever my denominator already is, because my denominators will then be the same and I'm ready to subtract. So my denominator here is a 3. So I'm going to break my Hershey bar into 3 pieces, and if I have all of them, I have 3/3 of a Hershey bar. So think about that on my top. I started with 14 Hershey bars. I took one away, which gave me 13 whole Hershey bars, broke the other into thirds, which was 13 3/3. So this one, if you think about it, I actually could have left it at the 13 3/3, but I didn't know that when I started. And sometimes it might have been a fraction with a different denominator, so I still like changing it to the whole number as I did on Sunday. But here we are again. We're on Monday with 13 3/3 minus 2 2/3. So I'm ready to subtract my fractions. Put my fraction bar, denominators were the same, they're going to stay the same, so my 3 stays. Numerators, 3 minus 2 equals 1. Whole numbers, 13 minus 2 equals 11. So for Monday, I see that she sold 11 1/3 gallons. Now, Final answers. I need to ask myself 2 questions if there's a fraction. First question, is it a proper fraction? Will it work in a chicken fight? Yes, 1/3 does work in a chicken fight, therefore it's a proper fraction. Question 2, is it fully simplified? Oh, my numerator is a 1, and if my numerator is a 1, my fraction is done. So my final answer is 11 1/3 gallons. Let's put that right into my answer line. 11 1/3. I'd already put the gallons, so that's perfect. How many gallons of lemonade did Jessie sell on Monday? She sold 11 1/3 gallons. That's our final answer to number 13. Okay, so we're ready to tackle number 14. Number 14 says, Jill baked a raspberry crumb cake last night. Billy ate 2/3 of the cake after Jill fell asleep. What fraction of the raspberry crumb cake was left when Jill woke up? So my question mark up to my asking word is going to be what fraction of the raspberry crumb cake was left when Jill woke up? Was left. I know that's a key word that means I'm going to subtract. So this is going to be a subtraction problem. Let's go back and see what I know. I know that Jill baked a crumb cake, so I'm picturing a crumb cake sitting out like on a kitchen table. I know that this guy named Billy ate 2/3 of the crumb cake. And when you eat something, are you adding onto it or are you taking away? Well, yeah, you're taking it away. Well, I guess you're adding it onto your belly, but you're taking it away from what you had originally. So the fact that he ate it, which means it's now gone, and the question says was left, all goes together with the fact that this is a subtraction problem. So I know that I need to subtract this 2/3. But what am I going to subtract it from? There's no other number in here. Jill baked a raspberry crumb cake last night. Billy ate 2/3 of the cake after Jill fell asleep. What fraction of the raspberry crumb cake was left when Jill woke up? There's no other number. What am I going to do? This is the biggest question that kids ask me, even after we learn it, even after we go over it over and over and over again. On tests, kids will raise their hand and say, but I don't know what to subtract it from. I want to remind you on a test, that's not a question I can answer. So we want to really focus on this problem because with fraction problems, you will see something like this very frequently. It tells me how much Billy ate, which is 2/3 of the cake. But watch this, he ate 2/3 of the cake. Well, this raspberry crumb cake was the cake. How much cake was it? It was 1 whole cake. Very often with a fraction problem, when you're starting with 1 or 1 whole, they won't tell you that the number is 1, or they won't say it's 1 whole. You need to figure that out on your own. Usually I know to do that when I get all nervous because I don't know what number I'm adding or subtracting with. So when I look back at the problem and there's only one number given, like in this case it's 2/3, and I say, oh my goodness, what am I going to subtract this 2/3 from? I have to step back and say, is there a whole thing or a whole group that I'm going to be subtracting from? And then in this case there is. It's 1 whole cake. So I'm going to be subtracting the 2/3 from the 1 whole cake that we started with. So I have 1 minus the 2/3 that he ate. So I'll take this problem and I will now write it vertically. 1 minus 2/3. Remember, 2/3 is a fraction, so it needs to be in its own place value fraction column. I'm ready to subtract. I have 1 whole cake. Can I give you 2/3 exactly the way that it is? Well, if that was a Hershey bar, can I give you little pieces? No, I cannot. So I have to borrow. I take that 1 whole Hershey bar or that 1 whole cake, and I'm going to take it away. So if I take 1 away, I have 0 whole cakes or whole Hershey bars left. The one that I took away, I'm going to cut into pieces, or I'm going to break into pieces. I can break it into any amount of pieces that I want. Since I'm subtracting, and when we add and subtract fractions, we need common denominators, it makes the most sense to break it into the denominator that I already have so that my denominators are the same. In this case, my denominator is 3, so I'm going to break it into 3 pieces. Again, I like thinking about chocolate. I have a whole Hershey bar. I break into 3 pieces. How many do I have? All of them. So I have 3/3. So if I have 3/3, I can give you 2/3. Denominator stayed the same, which is 3. What's 3 minus 2? That's 1. What's my whole number? 0 minus nothing is 0. So 1 minus 2/3 equals 0 and 1/3. So now let's switch back from chocolate to the actual problem, which is cake. And think about it. There was one whole raspberry crumb cake. Billy took it and broke it into 3 pieces. He cut it into 3 equal pieces, so he had 3/3 of the cake. He ate 2 of those pieces, so what was left by the time Jill woke up? It was 1 of those pieces, or 1/3 of the cake. For a fraction, if the whole number is 0, it's not necessary to write it. So I'm simply going to say that 1/3, what's my unit? Of the raspberry crumb cake. So 1/3 of the cake was left when Jill woke up. And that's my final answer. 1/3 is a proper fraction, and it is fully simplified because there's a 1 in the numerator, so I am done. So the most important thing in these types of problems is if you don't know what the other number is, look and see if it's one whole item or one whole group, because then you'd be subtracting from that number 1. Okay, so now we're up to 15, and it says, what's the value of the expression below? And I see a subtraction problem, 3 1/4 minus 1 7/8. I see multiple choice answers. All right, I basically need to find the value, which means I need to solve. So I have a subtraction problem, and in order to add or subtract numbers with fractions, I must have common denominators. What are my denominators here? They're 4 and 8. Those are not the same, so I'll need to find the LCD of 4 and 8. Start with my larger number first, which is 8, and then my 4. When I go through my 8 times tables, I say 8 times 1 equals 8. When I go through my 4 times tables, do I say 8? Well, yes, I do. So my least common denominator is 8. I'm going to rewrite these numbers with new denominators of 8. But again, these are mixed numbers. So a mixed number, I have to be very careful and remember to transfer over my whole number as well. So my top number, 3 1/4, I'll bring my whole number of 3 over. I'll make my fraction bar and put the LCD of 8 down there. My bottom number, I'll bring my whole number of 1 over. I'll make my fraction bar and put my LCD of 8 down there. The denominators came from that LCD. Okay, so now in order to figure out my numerators, I'll make my window boxes and set myself up. Let's look at my top number. What do I do to a 4 to turn it into an 8? Well, 4 times 2 equals 8. Whatever I do on the bottom, I must do on the top. 1 times 2 equals 2. Okay, what do I do to an 8 to turn it into 8? Well, 8 times 1 equals 8. Whatever I do on the bottom, I must do on the top, and 7 times 1 equals 7. So 3 1/4 turned into 3 2/8. 1 7/8 stayed 1 7/8. Move over my subtraction sign and my equal bar because I need to have that if I want to have any possibility of getting partial credit. And now I'm ready to subtract. 2/8 minus 7/8. You have to think about this as chocolate. If I have 2 little pieces, can I give you 7 little pieces? No, that's not possible. So therefore I must borrow. So I'm going to take one of those Hershey bars away from the 3 that I have, cross it out, and I'm going to turn it into a 2, right? If I have 3, take 1 away, I have 2 left. The one that I took away, I'm going to open it up and break it into little pieces. I can break it into any size pieces I want. So what size should I break it into for this problem? My denominators are 8, so I'm going to break it into 8 pieces. I have all of them, so I have the 8/8, which is what I broke that whole Hershey bar into. So let's rewrite this as my new number. My whole number is 2. I had 2/8 plus the 8/8 that I broke that Hershey bar into. 2/8 plus 8/8 equals 10/8. So this number has turned into 2 10/8. My bottom number stays the same, but I'm going to move it over to get myself ready for my nice, neat subtraction problem. Notice I have a subtraction sign and an equal bar. So I can do 10/8 minus 7/8. If I have 10 little pieces and I give you 7 little pieces, how many do I have left? Well, 10 minus 7 is 3, and my denominator stays the same of 8. 2 minus 1 equals 1. So I have 1 3/8. Now when I have an answer with a fraction, I have to stop and ask myself 2 questions, but remember, As we learned, sometimes with multiple choice, the answer choices may not be fully simplified, or sometimes with multiple choice, you may find an answer choice that is not a proper fraction. So when I have multiple choice, before I go through with the work of asking myself those two questions, I first look over at my choices to see if my answer is there. If it's not there, then I try to fully simplify. But first I check to see. So letter choice A was 1 1/4. Nope. Letter choice B says 1 3/8, and notice that's exactly what I have, 1 3/8. So I found my answer there in B. There's no need to try and simplify or anything else. Therefore, the final answer is letter B. Okay, that's numbers 11 through 15. Make sure you study those problems. And a big one to remember here was problem number 14, where they don't give you the number, and that means it's one whole, so you start with 1. Definitely make sure you focus on that in this grouping.